Models are only as good as the data they are trained on. And as it both, we care about data quality and we really take it seriously because we understand it's actually what directly influence will project will be successful or not.
I try to get the data foundations right because it's extremely difficult, it's super complex and the only way to do it is to start early.
When I became a data engineering lead, I really thought a lot, okay, I have limited resources with the team. I have a lot of organizational problem, how to create value of data, so how do I go about that? My default was, well, let's go back to the data product, let's think about the basics.
We had cross-functional collaboration at the source, where the data is created, between product engineering and data, and they all caring about what the data should look like, the goals and the metrics and the events. That resulted in better data, so teams became invested in shipping good data, which resulted in better decision, less of the phone number fiascos. So teams were making the right decisions that actually improved user experiences, which in turn sort of led more teams to be excited to do this way.
Nice to see you here. Great thanks to Ado for organizing this data feast, joining representatives of Slush for this important sharing of information when it comes to data. As I said, it's fantastic to see you here, and a bit break from the powerful Slush. I was there as well, you see? and it's great fun. I mean, a lot of excitement, but you get kind of exhausted, isn't it? If you stay there for a very long time. But I like it very much. This is kind of my favorite conference of all. You know, these diplomatic conferences are kind of not kind of more relaxed.
No neon lights.
Yes, no neon lights now. Yeah, I like it. It's fantastic, and it has been fantastic to see Avo watch and grow over the years, and we get big clients like Adobe, Fender, IKEA. Very impressive names that you have, and especially nice that the Finnish company Wolt is one of Avo's biggest customers and is participating in the event today. Hi Wolt, like your services. Wolt and Wolt, my favorite. Yeah, and also the company Supermetrics. Do you hear?
Yeah.
Nice to see you. Yeah. Fantastic. Great that you have such good customers here in Finland. It's fantastic. Cheers to that. Yeah. And it's an honor to be able to host this event today and take part in contributing to connecting Iceland with the Finnish tech scene and vice versa, and globally as well. Thank you. And let's do more of this. And next time, Slush, more events into my home. Yeah. Are you going to take over?
Sure. Yes. The first speaker, Elizaveta, do you want to maybe, are you
it's very fast, yeah.
Thank you so much for hosting us here in your home. We really appreciate it.
You're welcome.
We're mixing together the tech scene and the empathy life. That's perfect. And thank you everyone so much for joining us. I know there's a lot of exciting things happening at Slush, so we really appreciate it.
I am very excited to hear today's talks. We have great speakers today. We have Elizaveta from Wolt, we have Dan from Zalando, we have Jacopo from Wolt. We have an Icelandic saying for this, fire the train, be last on stage. Tell you a little bit about the Avo backstory, and talk about sort of building and maturing data cultures, and give you a sneak preview also of what's coming next at Avo also. So I'll do that at the end. Yeah, we will hear from these incredible people, and then after that we can have a chat among us. So enjoy.
All right.
And take it away from Elizaveta.
Yep. Hello, everybody. Good afternoon, and thank you very much for introduction. And indeed, it's a so nice place here, and I'm very great to present and talk about Wolt. So I'm Elizaveta, and I'm from Wolt, and I work as a senior data scientist there with focus on fraud domain, meaning that I'm mostly involved in building machine learning models which predict who are fraudsters, who are not, in all of our business lines. And also, I'm working on different kind of anomaly detection projects. I've been with Wolt for more than 5 years already, and it means that data science team at Wolt exists for slightly more than 5 years. So I've been there almost from the start, and I've seen how our team developed, how we've grew throughout these years, and experienced so many different projects which we've built so far. That's why today I will tell you about our data science team, and I will share with you how we structured, how we do our work. And second part of my presentation, I will share with you some different projects which we've built, and also I will touch a bit on this very hot topic of large language models. So now let's start. Start with this question: what does data scientists do at Wolt? Data science right now it's quite a vague term because many companies use it differently, and so do we. In some companies, data science is closer to data analytics, but at Wolt it's actually closer to engineering. And in other companies, you can see like such names of like SML engineer or ML scientist. And now a question for you: how do you think? What data scientist and software engineer both produce? Any ideas? Is there anything they produce? Again, data scientists and software engineers? No? Okay, they both produce code. At Wolt, software engineers, they live in TypeScript world, and they have their own packaging libraries, they have their own CI/CD systems, but their final product is backend services. And these backend services, they should be monitored, the code should be reliable, and also there should be alerting in place. As a data scientist, we live in a Python world and we use libraries from that universe. Similar to engineering, we have our own CI/CD systems, and we also care about code quality. We have different monitoring and alerting systems. But instead of backend services, we produce model endpoints. Another difference between data science and engineering at Wolt is that when engineers work on their tasks, they more or less know what needs to be built. But as a data scientist, we more or less know what the problem is. So we step in early in product development process when something hurt or there is some business opportunity to improve. Now let's look closer what this final product of us as a data scientist is. And the first, I already mentioned, these are models. So we build machine learning models, and then we deploy them on live endpoints, which are consumed by backend. When I'm talking about one model, for example, I'm from fraud domain, Rider fraud predictor model which predicts fraud. In reality, there are several model artifacts behind it because in both we may have city-based models or country-based models, and both operates in more than 400 cities. So there is you think one model, but actually there are hundreds model artifacts behind it. And obviously, it would not be possible to do all this locally. So you would not deploy all these hundreds of models from just this laptop. That's why we've built our own internal ML platform, which simplifies and facilitates all this process, allowing to deploy all these hundreds of models simultaneously. And why we also build this machine learning platform internally, because there is no any other person at our company who will deploy models for us. So it's data scientists who are responsible for building models and then deploying them into production. But when model once trained, it needs to be retrained periodically. And also we build the model training pipelines. Actually, it's also done with our ML platform because we want to retrain model use fresh data, and it makes them more accurate. Not all models, they need to serve live requests. There are some models which just produce batch predictions, and they are stored in ETL manners. Example of that is our LTV model, lifetime value prediction model. So when we calculate LTV for our users, we store it in ETL tables, and we do it like daily or weekly, so we don't need to do it for every live request. What else we do as a data scientist? Yeah, we do some research. We're like scientists, of course. Sometimes we need to do proof of concept for our blog posts, for some blog posts, for papers, or for our own ideas, because we need to validate something, maybe some crazy things which we think may work or may not. And it means that some code goes to trash, but some actually turns into product feature. So not everything we do, go live to production. But this actually research stage is very important because it allows us to understand what's actually feasible and what is not, and it's great input for product planning process. And last but not least, so we not only working with machine learning models, but also with experimentation, everything around experimentation. So we help a product team with a more complex business impact estimation. So product manager and analysts, it's good when they can do A/B tests, and then they can do it themselves. It's not a problem. But sometimes A/B test, or it's not feasible, or it's too expensive, and then we help with a more complex A/B test setup. For example, we do interleaved or switchback A/B tests, or we help with causal inference or simulation. Our data science team have more than 40 people right now, and we spread across 5 hubs in Europe. We have 2 offices in Estonia, in Tallinn, in Tartu, and also we have engineering hubs in Warsaw, in Berlin, and in Bucharest. But overall, I counted actually, it's yesterday, it's a very nice number. We have 100 ML pipelines. Because last time I presented a couple of weeks ago, it was 99, but it's already now 100. So nice number to put on slides, But by my pipeline, I mean business case solved. So for example, rider fraud predictors will be just one case. If you look at ratio of projects per data scientist, you see that it's not actually more than 1, but it's more than 2 projects per data scientist. And this ratio is somewhat special because there are companies where there are several teams working on just one model, but for us it's the opposite way, so there are more projects than people working. And I think it's I'm really glad to be in this position, and it's all due to our investment into internal machine learning platform, and this kind of resources which we put into building it really paid off through all years. So we've talked about this our team. Now let's look at what kind of projects we have. I will not cover all these countries for you today, no worries. I will just give you some sneak peeks into projects where I can show some visuals. And yeah, kind of starting with where Wolt apply machine learning. Everywhere. Like all of our 5 business lines have some kind of machine learning deployed there. And you can imagine if you do a write with Wolt, you enter destination and go to the destination. At point when write is finished, there are more than 200 calls, model calls being done. So it's a great amount of cases covered with machine learning at Wolt. Now let's look at projects. Okay. I don't have internet probably, and I cannot show demo. Just let me quickly fix it.
Do you want me to add the
I should be able.
Yeah, or the hey mode.
It doesn't work actually for me. Yeah, now it should be.
Okay.
I hope now it will work. And loading. Yeah, so basically I wanted to show you a demo of our driver license verification. So when our drivers sign up, they need to submit documents, and then we need to verify if this driver license is or any other document is valid or not. And we have a machine learning model which extracts all this information and then check it. So why we've built it? Because before it was our people checking this, and it's very boring work actually, because you would not want to just look at all this driver licenses the whole day. We wanted our people focus on more added value data, and actually this object character recognition, OCR, it's a known problem. And we built this model, and it's not only removed manual work, but also it decreased the amount of mistakes done. So when people review this for a long time, mistakes occur, but with models, we actually notice that there are much more or less errors. What else is important here is that we improve document handling time. So now drivers need to wait less time for their documents being verified, and it's actually good, better experience for them right now. And I'm really glad that some documents process completely automatically right now, and it's really cool, without any human involved. Next project which I want to share. So who of you seen this behavior on streets where you live? It's not even two, it's like a 3-person riding one scooter. And this poor man, like, passing by. This tandem riding, it's very dangerous. And it's not only dangerous for people who ride scooter, but also for people around, because they can accidentally be involved in that as well. That's why we've built a tandem detection model. So it runs fully on device. On a scooter, it uses data from accelerometer, engine current, voltage, wheel speed, and then it predicts is it a single or multiple people riding a scooter. Then when we detect tandem riding, we send the notifications because we want to push users for safer behavior. We want to make safer experience not only for people who use scooters, but also for people around, because we want to make cities as a safer place. Now let's look at another project. It's now for text domain. So if you use Wolt, you enter a destination, and then you usually see this list of suggestions, kind of which proposed to you when you can click and not type the whole address where you want to go. Before, we used Google APIs to create this list of suggestions, but as you see from this quick demo, sometimes it failed to give any results if there are too many mistakes, in address. Then we decided, okay, let's build our own autocorrection model. We did it, and we've noticed that it even has a better search quality. So as we used our own data to build this model, it was more related to our use case, and that's why it produced better results. And what is even more important, that we are now less dependent on other providers, and we save quite significant amount of money on that as well. So all the 3 cases I shared with you before, they are using unstructured data. But reality is that still, like, majority of cases where we use machine learning models, they use tabular data. Like in fraud domain, we kind of all of our projects using tabular data. I shared with you a couple of projects with computer vision and from text, but all these advances in large language models, they opened up for us more this area, and right now we are exploring where we could use transformers and could it bring for us additional value. And a quick example from this, so it's now from customer support automation. So when users write to us about their questions, issues, before starting to solving it, we need to classify what the type of issue this ticket is, because then we will redirect to specific engine who is dealing this type of issues, and it will decrease the resolution time for ticket. Before, we had a keyword-based search model, TF-IDF, if you know about it, and which classified these tickets. Results were quite good, but then we started to experiment. Maybe we could use transformer-based models for issue ticket classification, because our assumption was that it should be more accurate for corner cases, smaller issues, and also for cases where there are several types of issues in the one case, which could not be identified with our previous model. It's still like experimentation which we are doing, but what we've noticed already is that this model with transformers for CS ticket classification, it actually shows much better overall accuracy, and top 1 accuracy and top 3 accuracy. So it's quite good. That we are kind of opening up this sphere, and we already finding some something which we can use. But you know, like all these projects were kind of successful, but sometimes something goes wrong, and sometimes it's not all this data science work, like you just push your data and receive the good results. Sometimes you have challenges, and in the end I would like to share with you this one example which we had this summer. It will be from fraud domain. I will not go into details of what these chargeback files are, just grasp the idea that we had a binary classification model and we wanted to transition to multi-class classification model. So now instead of 2 classes, we wanted model to predict 3 classes. We kind of, at both, we experiment everything, and here as well, we wanted to do A/B tests to see what kind of performance we would get from this change. We planned the A/B test where 50% of requests went for our old model and 50% of requests went to new model. We started A/B test, but we planned it for 2 weeks, but it was shut down in 1.5 hours. This plot actually quite nicely illustrates what happened. Orange line was what we expected model, like on average prediction to give. But when we started A/B tests, this blue line kind of started increase. And the thing is that we apply several actions based on model predictions. So it started to affect good users, and that's why we were required to stop A/B test. We were quite frustrated with that because before starting A/B test, we did extensive validation on historical data. We did silent live, where model was actually live but not affecting users. And from that plot, you can see that expected and observed values during silent live, they were quite similar. But during A/B tests on that plot, you see that like how huge the difference was, and it's only for 1.5 hours. Of course, yeah, we started to investigate, and we spent 2 weeks checking different hypotheses. Maybe something was wrong with model threshold selection or score transformation. Then we also checked most important features. Maybe there were some updates done for these features, but we found nothing. And only then, when we started to dig in like less important features, we found 2 features where we saw changed feature distribution. So before we started A/B test, and after we before and after, there were like changes in the distribution value of that features. We started to talk to our backend team who are responsible for them, and they told, okay, on a day before A/B test, they did their refactoring for this feature. They didn't tell to us, because for them it's just refactoring, like nothing should break for sure. But we found that we asked them to investigate more, and we found that there was a bug in that refactoring, and it caused like this distribution of feature to change, and it affected model predictions in life. And we were unlucky that it was done right before our A/B test. We haven't noticed during silent life because there was a day between our silent life and A/B test, and what happened right on that day. But anyway, in the end, we found root cause. Everything was fixed, but it just shows how like data quality matters, and you should always be confident in what data you use. And to conclude, I wanted to leave you with exactly that message, that machine learning models are only as good as the data they are trained on. And as both, we care about data quality and we really take it seriously, because we understand it's actually what directly influences will project will be successful or not. Thank you.
I appreciate you sharing, and I'm really glad that you were able to, and that legal didn't stop you from sharing a driver's license right there. Like the driver in the iPad notebook. I'm happy you got the actual details of the driver's license.
But actually, that driver's license is totally official if you wonder about GDPR and stuff, so nothing.
So thank you so much. Next on stage is Jacopo, and while you set up, any quick questions to Elizaveta? Yeah?
Small question. 100 models and use cases is super impressive. Would you say ideas for new models or new use cases, do they usually come from the technical side, data scientists, or do they come from the business side?
It comes from both sides. some like products, they do their own planning and they're kind of doing long-term kind of strategies and they propose own ideas. But we as data scientists, we also include in this process, and sometimes kind of we know better what can be done. For example, we have anomaly detection projects, and it came from data science team because kind of product maybe they don't fully aware how it can be done, but for us we implemented this project and it was our initiative.
Are you feeling ready, Jacopo?
I think so. I just need to find my mouse.
Configuring the right screen setup, very important part of the journey.
Of course.
So I think I'll just let you take it away. Give it up for Jacopo.
1 second. It's a bit dark. I hope you can see the screen. I don't know why it's so dark, but.
You want it to be lighter?
Maybe. Feels. Oh, well, if you can see, it's fine. All right. So I just need to get my notes here. Yeah, that's great. Hey, hello, I'm Jacopo. Today I'll share some reflections on working on data during our growth journey at Wolt, and some of our challenges and stuff we learned on the way and things we tried. And at Wolt, I run our data group, which is the organization that's responsible of building our data environment and infrastructure from the data ingestion part all the way to our machine learning platform and stuff like that. I joined Wolt quite a long time ago. It's kind of a funny story. I replied to a message on Facebook, and that kind of got a lot of things started. And I ended up here in an empty office, and where everything had to be built from scratch, including everything related to data. So that was our first office. And sort of the first few years have been years of learning, a lot of coding that has been deleted, and a lot of code that people have to deal with today still. But one thing that we did at the very beginning is we sort of focused on opening a window over our business, and that sort of was the most important thing that we tried to do in the data space as well. When I joined in 2016, we were around 25 people in the whole company. Today I think we just crossed 10,000, something like that. So it's quite a journey. And of course, we could do many things back then. We had a product that worked, that people used here in Helsinki. We were about to open in Sweden, so we could have gone many different ways. But what we decided was to focus on the business, so understanding how our dynamics out there in the world, our business dynamics would work. So we sort of started to build this common and centralized way to look at the business, and focused on that for many years. It's kind of funny because this was our first data warehouse. So we just had a button in our internal tool where we could download a CSV of data. I hid some of the identifiers we had there, but there was no PII here, just orders, timestamps, and stuff like that. And then that got loaded in an Excel, and people could just write some formulas and come up with some numbers and understand how much money we made or we lost per order. And sort of that's the velocity that's how we got velocity in this sort of area, like trying to get things in an interface that made most sense to the people that could really make these decisions and craft how we looked at the business. And when I joined, we were about around this time. We were building this, and we sort of started to look at how do we sort of automate these things and make them better. And as the team started to grow, a lot of people wanted to get more data to make more decisions faster, or the decisions they used to make, not bugging the person who ran this Excel, which was our CEO. And we sort of made a lot of mistakes. We took into use a lot of different tools, and sort of we then had a lot of migrations where we asked people what's important, what would you like to move to the next tool from the previous tool, and it was such a painful process. I think it took us 2-3 years to get to a stable environment where people were happy with the tools, and sort of we were able to just focus on building on top of the data that we started to collect. And nowadays, we sort of look at the business still pretty much in the same way we used to look at it in that Excel. As an example, in one of our internal tools, we have the same representation of the business that we have there, and now it's fully automated. But we sort of didn't need this at the very beginning. We didn't need it in 2016, but it's great that it's here now, and it's a continuation of what we used to do. And that's sort of the focus on the business. But of course, focusing on the business is one thing, but at some point you want to probably start to build better products and iterate the products you already have. And we found out very fast that knowing what to build at a given time is pretty hard. We used to have this one app that really worked well. It was a list of restaurants. People could browse and buy food from there, and that was pretty much what we had. But when you are small, you don't need to overcomplicate things. You can just go into a room, put some big Post-its on a wall, decide what to build. All the people are in the same room. You write stuff that we still haven't built. It's there. It's on that board. Yeah, that's a roadmap already. The current roadmap as well. And you can have your CEO joining the party and writing something on the board, and then decide to build something. And that's sort of how we built the app back in the day. So that was Wolt in 2017-ish, just a list of restaurants, then adding maybe some tabs so that people can actually search and not just have a list, and then giving a possibility for people to review. And then on the way, sort of we also won some awards. Apparently, the app wasn't that great, but apparently people really liked it. And at this point, we were like, okay, we have this. What do we build next? And we sort of, and how we build it. So we sort of took some side tracks here. So we started to build what we felt was missing. For example, this is our discovery page. It's pretty much the same today. You can find, instead of a list of restaurants, many lists of restaurants sorted in different ways. And sort of then we sort of decided, okay, let's build some social features. Everybody in 2018-19 were building social in their apps. And when we did that, no one has ever seen this because apparently people want to order food when they use a food app, and they don't want to go and review. And then when they review, they usually review, oh, your order, my order was cold. That's not really helpful, So we did a bit of what we felt it was right, and then we sort of went into this strange experimentation journey too early, and it wasn't really successful back in the day. It wasn't really clear for us how to experiment. But back then we made this decision that we'll build a product that we feel is right and we would love to use every day while we optimize the business on the side that I showed a bit earlier how it happened. And we sort of focused on building the teams in a way that there would be quite clear responsibilities, areas that each sort of a team would own, and so that they would be able to build processes and try to understand like where we needed to be deep in one field. For example, we went very deep into trying to understand like how customers would want to behave would want Wolt to behave when they have a defect in their order. So really going into that, going to talk with the customers, what would they value, what would they definitely not want to experience, and sort of we built those features, our customer support, our internal tools, etc., etc. But now we got so far, and yet we have one thing to crack, and it's becoming more and more relevant as kind of we are growing and we are running the business in the way we are running it today. And this thing that is quite hard to crack is how to learn from the users using our product. This has been truly hard and extremely complicated because nowadays we are live in, I think, 24, 25 countries. We have a lot of people using our product every day to do different things. You can order food, but you can also order a fridge to be delivered to your home in some countries. And anything in between food and fridges we deliver in some of our countries. And we can deliver it through Wolt, or we can deliver it through the restaurants or the stores own a delivery service. So it's super hard to understand how people are actually behaving in different situations, and you can only interview so many people. And we sort of started to focus a lot on this, getting the data right to support understanding what the customer is doing without actually having to talk to the customers. And this has been the focus of the past couple of years, but has been, I have to say, it has been one of the hardest things. Also because Wolt is quite a complex company nowadays. In our engineering, we have around 700 people at the moment, and 100 of them across more than 10 teams are building our consumer app and Wolt.com, which are our touch points for the user, the users. And even if we started in 2017 building a framework for tracking, which is a good thing to do if you want to understand how people are behaving in the app, you probably want to collect some data, and probably you don't want to collect data in random ways. You might want to build a way to formalize or have some sort of agreements on, like, for example, what is this thing that the user is saying is probably a view. In our case, is a view. And within a view, the user can do different things. For example, it might be able to receive some data from somewhere that gets rendered and turns into something that the user is seeing, some impressions that the user can interact with it, with this view, causing some effects, like a navigation into a different view and stuff like that. And then find some unique identifiers that you can share so that when you send this event somewhere, it's always called in the same way. So we have built this already in 2017, but we made it extremely hard to use. We actually probably chose one of the best interfaces, but one of the worst. We've wrapped it in one of the worst tools possible. So what we did is we sort of created this incredibly complicated YAML file. Nowadays, apparently, this type of work is super, let's say, everybody is a YAML engineer nowadays in one way or the other. So we tried that already in 2017. It wasn't a great experience. But we sort of ended up in a situation where people knew what we wanted to track, but they didn't know if it was at all tracked. So that was the spec. And then we were receiving some data, and we weren't really able to make this specification talk with our products. But that was a good idea, and it sort of survived. And we are nowadays collecting around 800 different, up to 800 different event typologies from the app. Sometimes we want to know, for example, a specific, what kind of content was there when the user went to a specific view, for instance, or what sort of estimate was shown in a specific tile in our discovery view and stuff like that. And all these things need to be specified so that the engineers can implement them correctly. And we sort of, this sort of idea that we would need to have this sort of contracts for data tracking and from all the way from the design stage to the further end of the funnel has been quite well received at Wolt. We know how to produce YAMLs, but we sort of had some sort of problems to bring everything together so that it would be seamless. And we started, I think last year, to investigate what kind of setup we could have, and that's when we met the nice people at Avo. And nowadays we have, I think, around maybe 30, 40 people within our engineering organization and analytics organization that can meet in one place to actually do this thing that we were doing in our YAMLs, but more also try to understand if these events that we are tracking are actually tracked properly. So this has been quite a nice discovery, and it's a very well-loved tool. But we also sort of thought that, okay, if we stop here, just having one interface doesn't really work. So this time we really try to get into the minds of the engineers and try to figure out how we can make an integration with their tools seamless, because what we notice is that you can sort of make the best specification possible, but at the end of the day is the implementation phase that's a challenging one when you go and code it on your laptop. and package it into the app. So we really focused on the ergonomics, and we had some of our consumer engineers, especially on web, adopting and wrapping this into an SDK that we're using nowadays to do the tracking there, and where people can find all the events we want to track with all the specifications, with all the tracking agreements, and then they can go and when they code, they can actually see if they have problems with the implementation, they missed something, or they can actually use these helpers that we built in the SDK to write tests, so that mount a view and then see, is the content rendered correctly, and does it produce the right side effects? So that has been quite a big effort on our website, and we are now trying to reproduce this on our consumer applications, which is challenging, but if we manage to do it on web, we will definitely manage to do it on our native apps as well. And yeah, a lot of testing going on there. This also helps us to build a better machine learning models or better analytics by having better data. Yeah, so we managed to kind of do this sort of developer first in a way, but we also had to write a lot of guidelines. I think this is our tracking guidelines internally. So there is, I don't know how long is this document, but it's quite a long read, and we sort of decided to do it in 2 ways, and that was a really great discovery, and maybe also an advice to everybody who is trying to implement something like this in their companies. The documentation is never for one persona. Like, engineers want to have documentation written for engineers, and analysts want to have the documentation written for themselves. So from their point of view, like, here is how we write a spec for an event, and here is how we take that spec and actually write some code that can produce those sort of pieces of data. And then kind of integrate that stuff that you're building in your internal tools is also a great incentive for people to care about. For instance, we build in Data Group our experimentation platform as well, called Regatta. And we have the possibility to customize this how we want. And one of the things we are working on this year is to bring in our telemetry, so these events, into the experiment specification, so that the analyst goes in and says, hey, this is the experiment I want to build, I want to run. I really need to get these events right. And then being able to loop back and saying, hey, these events aren't actually right, so you shouldn't really start this test, because in the latest application versions we released, they are broken, by the way. So go and fix them. So having everything talk together has been quite a good choice for us so far. I think that's the right direction. And of course, we want to take this approach beyond the apps. And this is the last thing I wanted to talk about. And sort of if in the applications we have problems because we have something like 800 events, outside of the applications we have even more problems. Can anyone guess what has changed just in the past 6 months from 144 to 230 at Wolt? All right, I'm going to help you here. Data registries. So in our teams, we have over 230 databases in production right now backing our services. That's a lot of databases, and every single database contains pieces of information that we need to gather in order to understand how Wolt works in the wilderness. And this has become quite overwhelming for us, because we sort of need to, in Data Group, we need to do a lot of data integrations on these databases and source a lot of data for our analysts to be able to do their job. And we are trying to find a way to codify these sort of responsibilities beyond the application analytics. And we are sort of now in this journey of trying to dive into this topic of data contracts and moving more towards this sort of event-driven architecture, similar to what we have in the apps, but for data warehousing, where people can say, here is what I'm responsible for, here is how it looks like, here is what this data set is for, and we are very, very early in this journey, but we are sort of building our tools, our newer data tools with that in mind. Although it's super difficult because we are replacing like 8 years of legacy right now. And yeah, we also opted for this sort of YAML interface after all, where we sort of are building in our internal data management tool all these sort of abstractions to tell people, here's how my data sets should look like, here's what they should contain, and here's how they are generated. And we are sort of taking this approach beyond our in-app analytics also into the rest of our data world. Yeah, if I have to say one thing to wrap it up, try to get the data foundations right, because it's extremely difficult, it's super complex, and the only way to do it is to start early, especially if you are sort of a new company or you are starting some new project and so on. So fixing these things later is mega painful. I can say that. Yeah, so that's what I wanted to talk about today. Thank you very much. I'm happy to answer questions about what we discussed so far.
Nice.
Thank you.
And while we talk a little bit about Jacopo's talk, feel free to start something up. Welcome to my new, also, this is the newest our team member, my daughter, Olafsdottir. And give it up to Dan.
Hi everyone, so I'm Dan. I'm a data engineering lead at the Zalando Emerging Propositions Stack. I'll speak a bit more about data products and data mesh in practice of how I basically think about data products. So my journey at Zalando, I've been at Zalando for 7.5 years. I started as a backend engineer. And then 4 years ago, I decided I really want to dive into data science world, so I started a master's at Alto in data science and switched my work as well for applied science products. While I was doing internal research, I found out that maybe the most painful job of the machine learning engineer or data scientist was the data preparation. It was extremely painful. So I decided to try to do something about it, and it's been a pretty rewarding journey, and I'll be sharing my thoughts now. So a bit about Zalando. So Zalando is an e-commerce fashion platform in Europe. So we're in 25 countries. We have more than 50 million active customers and a GMV of 14.8 billion euros. So Zalando's data lake in a nutshell. So how we got to the data lake or data mesh approach in the first place. So the next two slides I stole from my old colleague Max Schulz and the partners at ThoughtWorks. If you're interested to learn a bit more about the data lake setup, go to YouTube and type Zalando Data Lake. There's a great talk at the Databricks AI Summit of how they initially thought about our data lake. I think essentially it's built on the ingestion side. Our event bus, it's basically a huge Kafka cluster. It's our own implementation called Nakadi with strict schema on write enforcement, where all the schema is part of the application layer, as well as also our client events go through our system called Tracken, where we manage the pseudo-anonymization and consent, and then everything flows to our S3 lake. We still have our legacy data centers and web tracking, but yeah, everything in the end flows to our S3 data lake based in Parquet or in Delta, which is a Databricks native file format. We still have the Hive meta store, which we're collecting all the metadata, and that flows to our data catalog, which is based in Collibra. Our processing platform is based on Databricks, so we use Spark, so Scala Spark, PySpark for all transformation. And then we have a federated query layer based in Presto to get quick insights of all the data that we have. And then that's his next slide. It's pretty popular in data mesh. And that's how they also thought in setting up this data lake for Zalando. And I want to dive a bit deeper here. So in my previous version of this talk, I think a lot of people were interested, like, okay, how do I then define our domain? Or what is a customer? So I think the way I think about this is you can think about at a very abstract level, what is a customer, what is a checkout, but I think because we deal with actual engineering systems, that has a lot of repercussions of how then we organize smaller business units or teams. So I think at the moment in Zalando or in companies such as Spotify, all the domain teams are organized in type of squads where we have a really cross-functional team asset. So we have iOS, Android, and front-end engineers that can basically own some microservice in the front end, and they basically manage the whole data lifecycle. Then maybe you can have the rest of the team composed by backend engineers, by machine learning engineers, or data analysts to basically own everything end to end. And I think one of the challenges here is also that the data models can get pretty complex, especially depending on the architecture of your organization. So a team might have, I don't know, 30 microservices. Maybe you actually moved everything back to a macro service where everything is contained into one single service. So basically then that becomes a domain. Myself and my team, we work closely with domain teams, but we're mostly on aggregated domain level because we deal with pre-owned, we deal with designer, and we deal with beauty articles. So we have to prepare some more specified domain there. And everything is provided as a data infrastructure. So we have the Kafka as an infrastructure, Databricks, Airflow as infrastructure, as well as S3 Archiver and Zflow for machine learning based on SageMaker. So when I became a data engineering lead, I really thought a lot, okay, I have limited resources with the team. I have a lot of organizational problem, how to create value with data, so how do I go about that? And my default was, well, let's go back to the data product. Let's think about the basics. So I found this data mesh, the data product Canvas, and that was like really inspiring for me to actually maybe lay down, okay, what is the most important thing? So of course you have the customers, you have the use case, what are they interested to learn about the data? You have this classification, so okay, is this a high value data set? Is this maybe not as important? Does it deal with some ubiquitous language? So for example, when we deal with logistics, they have some very specific domain language, like this is a truck, this is a pallet, this is rerouting. So obviously data engineers, and analysts or machine learning engineers, they need to understand basically each other. And then you have, okay, the data product design itself, a lot of metadata, the ownership, the schema, the semantics that you need to basically track, as well as different observability metrics like SLO, SLA, different data quality metrics, as well as operational metrics. So how fast, for example, can you query the data? And this is, so in Zalando, I had the pleasure to work with a lot of really talented product managers, and we really learned to love the 4D process of how to deliver product features. There was not really enough such canvas for data products, so I came up with this myself in order to how to think about the data products itself. So in the discovery phase, of course, you have to identify stakeholders, so who's going to use your data. You have to solve some specific customer problem, and I think most important, you have to establish target and control KPIs. So target is a KPI that you wish to improve, and control KPI is something that you don't want to damage, so like customer experience or the GMV and so on. And the design phase, at least in the interface mockup, is something really interesting that I try to involve our analysts a bit more and more to work more agile. So the default thinking usually is, well, just provide us the data and we'll figure out what we can do with it. The approach is slightly changing, so we're also trying to learn what they're trying to achieve. So they also try to iterate a bit more on, okay, what exactly are we looking out of the data? Do we want some more cohort-based approach, or do we want some more segmentation? So in the end, we also try to come up with better data architecture, and then maybe algorithm selection when we talk about machine learning. And the develop phase, of course, we have data collection, cleaning, transformation, model training, validation, and actionable insights. So if we have to develop, deploy a feature, then also have to make sure that we know how to track it and that it's accurate. And the deploy phase, of course, production testing, performance monitoring. But I also think it's important to gather the user's feedback, who's going to use your data product, as well as provide them good resource and support of how to maybe solve their issues themselves or escalate if needed. And how to measure impact. I think for me, at least, it's really important, the role of data models, because I think it's important to have a unified language between business and technical teams. I think as a data engineer, you often find yourself in a position where you have to understand and translate business requirements into structured formats. So I think it's good to get everyone from analysts, engineers on the same page, and it can be a good foundation for data science and analytics. And yeah, scalability and flexibility. So good data models are scalable. So they have to be forward compatible in a way that you can keep adding new columns or whatever your data product is requiring. Changing data sources, so you can have different, more abstract data models. For example, if you do a migration, you don't the stakeholders don't need to query directly the raw data. And yeah, being flexible to adapt to evolving business needs. How to measure your data product impact. So I think most important is the data integrity. So ensure that you have reliable data sources and you maintain data accuracy for data products. You have a continuous feedback loop. So the data products is not a static thing. It evolves all the time and you'll have to refine your data models. So it's important, as I said, to get feedback from users and stakeholders. How are they using it? Scenario analysis, I think it's pretty good if when, for example, you're deploying preparing a new feature, you do some sort of risk assessment. So for example, if you have a high value data set that then is providing P&L financials for your company, any potential impact can have pretty drastic impact. So it's good if you assess already the impact beforehand and you maybe have a playbook ready what is going to happen then. In the measurement, I laid down here 3 important ones. So the quantitative, so accuracy rate, processing time, and customer metrics, as well as qualitative, so getting the user feedback, the usability and perceived value. And then of course you have the classical A/B testing, or for example difference if you don't have the luxury of the A/B testing itself. And how to come up with good data models, I think it's good to have a collaborative environment where everyone can get on the same page. So organize cross-functional workshops. I think it's important to have everyone from business to data science, analytics, engineering continues to refine data models together to understand what actually drives the business value. I think it's super important that there is a shared ownership. I think, for example, data engineering itself, we cannot own all the data itself because we're not the producer of the data. Likewise, for the engineering teams, they cannot own all the data because maybe they produce and they can have some basic accuracy metrics, but they do not know how then the data is used afterwards. So it's good to have this kind of shared ownership perspective. And the clear communication, so you should maintain clear channels of communication between teams. You should give regular updates, documentation, and as well demos to make sure that everyone is aligned and informed and know more about your data product. And last but not least, so the importance of open schemas. So as I mentioned, we store all the schemas on application level, the ones that are used for Nakadi itself, and then we have another data lake layer schema that manages all the data governance. So I think it's good for transparency because, well, if you have a PR that, for example, breaks something in your data quality and your data lineage, it's important to know how to track back what change has broken what part of the data lineage graph. Stakeholder findings, so actually we also encourage everyone to collaborate in Git with us to make sure that they understand the data model and they find the value in this. Managing data model evolution, so if you have clear documentation and open schemas, you can track changes, but also, as mentioned, you can evolve your data model and is a base of data governance. So in the data model itself, you can define the ownership of the data, all the different PII columns, and you can also have different compliance for the lifecycle definition. Like if you need to delete the data after some time, I think you should do that, or maybe create models that are more aggregate level, since we don't need all the little details. yeah, I think that's it. If you have any questions.
This, we can, to the folks that registered to the email, to the event, we can send over also some ways that you can reach the speakers so that you can ask questions if they are inclined to be reachable. But in all cases, I think we're all on LinkedIn, so we can always touch base there. I want to talk a little bit about maturing data cultures and taking them from winging it to a state of self-serve governance. Before I do, quick introduction to myself. I am Stefania. I am the CEO and co-founder of Avo. I have been in data science for over a decade. It was weird when I started counting in decades and not years, but that happened during COVID. I started in, I'm touching the mic right now. Not touch them, but don't touch the mic. I started in data engineering in genetics. That's what I was first doing, managing distributed computations for really complicated data sets, and then designing shell script interfaces for doctors to query that data. And that was back in 2011, I think. It was a lot of fun. I learned how to treat even shell script interfaces as products. So I am very passionate about that. And so, of course, that's one of the data mesh principles, is data as a product. So I'm excited to talk about that today. And then from there, I became the founding analyst of a mobile game called QuizUp. And I don't know if anyone here remembers QuizUp, but it was the fastest growing app in the App Store at the time. They reached out to me to join when they had just reached 1 million users in their first 5 days. So that was pretty impressive. It was a record that Flappy Bird later beat. I don't know if anyone also remembers Flappy Bird. So that's very good. Okay, anyway, so that was that journey. And when I joined QuizUp, we had a lot of data mess. Get it? Not data mesh, certainly not. I joined, and my role was to figure out, why do we have a group of people that join and they play a game, and then they just continue to play a lot of games, and then they find a partner, and then they get married, and they do all of that through QuizUp, and then some people just join and just don't even finish their first game. And what's the difference between those people? And these are terms like retention. I don't know who here is familiar with the term retention, but back in 2013 when I started this, it was not a lot of things that you could find online about it. This was basically product analytics before it was called product analytics. And if you Google retention, you would find it's the opposite of churn. And then if you Google churn, you would find something like, it's when people switch phone companies. And I'm like, okay, how do I apply that to a mobile game? But of course, we had like really great, we had a fantastic board, a board called, which included investors like Tencent and Zynga. Tencent and Sequoia people, and people that had been working with Zynga and had been working with YouTube. And so we had like front-running people helping us define how we should measure these things. And so we were really smart and started measuring these events that Jacopo was talking about earlier. Except there's a lot of different people that touch the code base to actually implement those events in code. And so you end up with all of these permutations of the same user action to start a game. And what that causes is like people make wrong decisions because they have just parts of the data. And I have a real life story about that, because after QuizUp, I and a couple of friends, we started another company, and it was a gamified microlearning for employees. And we were just like 3 months into it or something, and we had the exact same problems. And the story is, we realized that 98% of our users were using the email sign-up method. We were looking at our data for account created, and we saw that 98% of our users were using email, and we were like, okay, let's use this opportunity to simplify the onboarding journey. Seems like a pretty straightforward decision to me. All right, but this is what happened. So we had the sign-up conversion. It was hovering around 81% from people downloading the app until they completed creating an account.
Then we removed the phone number sign-up method, and all of a sudden it plummeted. We're like, what happened? And of course, as a trained data scientist, my first, hunch was to take a look at the data again. And lo and behold, we had a phone number property. And I don't know how many people in this room I should have set trigger warning for. But this is happening all over the world, every day for huge organizations, but also small organizations. This is the reason why at QuizUp we had built internal tools, like Wolt has done like a lot of internal tools. We had built our own internal tools to solve this problem, and I'll talk a little bit about that, sort of how we thought about that, and then how we sort of eventually built Avo as the same ideology, because just from this seemingly tiny typo, right? Someone somewhere spells phone number without a B. It seems so minor. We made an incorrect product decision. We had weeks of works of implementing, the change of the updated onboarding flow. Then we had more work to reverse the change after we realized the data showed us that we had dropped the sign-up conversion. And in the meantime, we had a severe hit to our sign-up conversion. So it's not a pleasant journey. And this is, like I said, it's happening all over the world to all sorts of companies because of these tiny, seemingly tiny typos very early in the journey of a data point, of an event that represents a user journey. Okay, so how does this happen? Let's talk a little bit about the typical analytics workflow. It starts with a product change. Someone decides that they're making a new feature, okay? And they do that in whatever tool that they're working on, like that feature in, all right? And then they go into defining sort of metrics and event structures to measure those metrics. And that happens typically in a slightly different tool. Like you have a Figma for product changes or a doc, and then you go into a spreadsheet and you define an analytics event, or an Airtable, or just ping a developer on Slack and are like, are you able to track this new feature? Or someone also, like some people have like graduated to the next layer and have like a JSON schema for it, or a YAML file, like we saw earlier. And then we sort of go into getting feedback and requesting implementation. So the people that have been involved so far typically is a product manager and an analyst, and they have like different perspectives on this. And then you get developers involved. Ciao. You get developers involved, and then you ping them on Slack and are like, we're thinking about implementing it this way. How do we? Or does that work? Do we have the right code for that? Does that work? And they give feedback, and they're like, I'm sorry, we can't implement it this way. We have to change it. But that happens through a conversation, and already the spec that's defined here is outdated. It's already outdated before even we start implementing. And then we go into implementation, and we end up with all of these different permutations of the events. That doesn't happen in a single developer session, but it happens across multiple developers that are touching the multiple touch spaces where you can add a song to a playlist or something like that. And then they use their human eyes to compare the data, where the data ends up in, to the spreadsheet that's already outdated. And they catch some errors and they push it back, and that's like a begging, it's like, oh, please, sorry, developer, I spotted this bug and please fix it. And everyone hates it, and it's really frustrating. And then we ship to production and we start using our data, and then we catch more bugs that we didn't catch with our human eyes. And this is the typical analytics workflow, and that's how that happens. So it's painful. So let me see, is this working? Yeah. So let's look a little bit at the evolution of the data maturity. How do people go from winging it to this Wild West state to something of a centralized governance to a self-serve governance? Basically, we go from no data to bad data to slow data to great data fast. And so that's sort of the encouragement that I want to think, or sort of encourage you to think about here today. Is where are you and how might you get to your self-serve governance stage? What does this mean? Winging it is just like we have to start there. We don't have a product. We have to make a gut decision, and we have to start somewhere. And we just have to figure it out. And then we go into the Wild West, where we have multiple teams maybe, or like just everyone is running on their own, and that's how we end up with all of these permutations of the game started event, you know? And we're not necessarily syncing to the other feature teams or the other domains about how they're implementing their analytics, and then we realize that that's a problem, and we start to there's a person that sort of ends up with the role of owning governance, a person or a team, and they don't really necessarily love doing it. They're like, oh, I'm sorry, but you have to comply to these standards. And they always have to be like, oh, well, actually, you know, this is not the way that we used to do or want to do it. And it's like, it's not typically a fun role. And it slows down product releases, which is pretty frustrating because, you know, maybe you have a product release that's ready to go out, but then there's a data person somewhere that's like, wait! And you're like, no, let me just ship, you know? But there is a utopian state here, and typically what I see is like people are in all of these stages at the same time. You know, everyone is not perfectly in self-serve governance, but you know, you sometimes have like people all over this, but ultimately you want to reach this state. And it just so happens that this coincides really well with what the data mesh principles represent. And they can be a means to an end to get there. So I'm going to talk a little bit about that. But before we do go there, I just want to encourage you to think about these four sort of how might we get to self-serve governance and what does that look like? First of all, you treat your data as a product, and we've gotten a lot of insights on that already from the speakers today, how to think about your data as a product. You follow all of the best practices about product development. You think about, like, you read books like Marty Kagan's Inspired, and you think about like usability, feasibility, desirability, and viability. You think about these things, and you develop your data products like that. You always include your stakeholders, really important, which is just a part of treating your data as a product. In general, it's about balancing global and local requirements and global and local governance thus. I think it's really important. And then I think one of the most important elements here is making analytics a part of the product release. Not as an afterthought, not as something that like a data person somewhere has to think about. It's a part of what the product team is actually responsible for when they are developing their products. Then they are also responsible for saying in advance, before they kick things off, they are responsible for saying, we want to move this needle and here's how we want to measure it, and these are the event structures that we need for that, and now we're going to go build the feature. And I really recommend that. I've seen that convert developers from, and I think I have a slide on this, no, it's later. I've seen doing this, like the making analytics a part of the product release, I've seen that convert developers from being in the mindset of thinking about analytics as a chore that they have to do for an analyst somewhere in the company, to starting to see it as one of the fundamental tools that they have to build better products. And I think that's really empowering. I'll touch on that a little bit later, but recap on the data mesh principles. So we already heard a lot about that already today. It's domain-oriented, decentralized data ownership, right? Okay, domain-oriented meaning feature teams or, you know, finance or something like that. Those are the domains. Treating your data as a product, self-serve data infrastructure as a platform, the ability to serve yourself for some of the fundamental things that you need in your day-to-day job. Self-serve is like a hot topic, I know that. I'm not saying everyone should be able to do everything with data. I'm not saying that, but I am saying that you should be able to do some of the fundamental pieces of your day-to-day work through self-serve. And then some sort of a federated computational governance. What does that mean? Federated, centralized. You know, global governance. And computational meaning it's not just people setting like suggestive standards maybe, it's also some way of validating data at scale, you know. Okay, so if we look at the journey from winging it through to the Wild West, through to the centralized governance and the self-serve governance, what does that look like? Okay, winging it, obviously we just have nothing, okay? Then we go into the Wild West. All of the variations of the song played and all of the variations of the game started. we sort of have domain-oriented ownership, right? We have like every team for itself, you know, they're just running and making it work for them. Definitely not treating data as a product. We sort of have a self-serve platform, but just for your domain, you know? You don't really have access to anything beyond that. You don't know what the data means, you don't know how it works, you don't know how it plays with your data, and maybe it's even a stretch to say that you maybe have it for your own platform. I don't know, but you definitely don't have federated governance. You go into centralized governance, you lose sometimes that domain-oriented ownership. That's sort of like it's a difficult state that you sort of have to go through, maybe for a while, where you sort of are trying to take control of what's happening. It's not necessarily what you want to happen, but it does happen. It's like people don't feel ownership anymore, maybe. And you're trying to treat data as a product, at least. That's what you're trying to do. You're trying to create a self-serve data platform. You might be still in a state where you have to though wait for like some sort of a centralized team to do some computations on your data before the domain teams get it. Not an ideal state, but you know, the ultimate, you're trying to create this. And then you definitely have some federated governance. And then you go into self-serve governance, and there you actually have teams shipping their own data from the beginning, and they're able to use it as soon as they release. They don't have to wait for a BI team to make any changes to it, or computations, or a data engineering team to make any changes to it. Just as soon as the product feature is out, you can check how it went. That's the ideal state. Domain-oriented ownership, data as a product, self-serve data platform, but you're doing it all in a way that sort of fits within the global scale of what the company is doing. And this is so exciting for me personally right now, because we have some very big customers, and they are all struggling with all of these. And so far Avo has been able to serve them in managing getting to the self-serve governance. I typically see generally companies going from this, but also there's just the industry is going this way. And right now we're literally heading into a phase where we're going to be adding even more support for like the interplay where you can balance the local and the global governance. So that makes me very excited. So where to start? Just want to sort of leave you with that thought. I always recommend starting as small as possible. Don't try to boil the ocean, as we say. And don't start with your North Star metric or anything like that. That's like a huge undertaking to get that right, because that'll need a lot of domains, for example. So start by thinking about this for your next feature release. How can you make analytics a cross-functional team sport for your next feature release? Inspiring developers to think about it as one of the most fundamental things that they have to build their products. I recommend this thing that we developed at QuizUp called Purpose Meeting. We have a blog post about it. If you Google Avo Purpose Meeting, tracking the right metrics, something like that, you'll find it. Aligning on goals initially. What does the success look like for us in this? Why are we doing this? Committing to metrics. What specific metrics will we use? We're going to use day one retention for the people that ended up seeing this screen or something like that. And then designing the event structures. And we sort of ended up doing this as a quick sit-down, 30-minute sit-down, and literally doing this, it just really changed the game in the commitment for how people thought about data quality. I would say, you know, sort of we ended up creating a reinforcing cycle that then became contagious around the entire organization, where we had cross-functional collaboration at the source, where the data is created, between product engineering and data, and they all caring about what the data should look like, the goals and the metrics and the events. That resulted in better data, so teams became invested in shipping good data, which resulted in better decision, less of the phone number fiascos. So teams were making the right decisions that actually improved user experiences, which in turn sort of led more teams to be excited to do this way of working. And we did this at QuizUp, and I've seen countless companies at Avo sort of gradually adopt this. And We like to call it sort of self-serve governance workflow. You basically, this has some Avo visuals, but in general, just think about this analytics release cycle in some way and have some structures that manage and tools that help you make this more efficient. So in general, you're analyzing and learning, and you make some product changes. You plan your analytics update in a structured way, ideally metrics first. So we're doing the playlist funnel, and for that we have the playlist created, the song added, the playlist added, all that's the playlist played. We get some review and approval, ideally in the same sort of tool and solution. We have some way, a linter of some sort to verify that the events are in the right structures. So song added as a camel case is not allowed in this global governance environment. You want it to be song added title case. And so try to not have humans do this work. It's just very frustrating for everyone involved, and it's very error prone. But that's a good place to start though, committing to a case. And then some way of automating the analytics implementation validation. At Avo, we provide type-safe SDKs, and that's a very common way to go, generate SDKs based on JSON files. And then for the validation purpose, think about that as some sort of observability solution, but have it as early as possible. Don't have it only downstream. We have like all of these, we have layers of observability. We have upstream, midstream, and downstream observability and data quality. And Avo is really focused here on the cross-functional collaboration at the source of where the data is created. And so you get immediate feedback that your events match the specification. You want that. So build or buy an internal solution or buy a solution that gives you instant feedback on whether the implementations actually match the specifications. And then make sure you get your schemas also downstream. So you in the end, you don't want your schemas and your documentations of your events to just live in one source or to just be in the place where you define them. You also want them where you actually use them. And then continue the cycle, just in a more streamlined way. I wanted to end with this really exciting sort of like sneak preview of what is now coming soon. We have been focused a lot on that sort of observability and validation stage for a while, called Inspector. And we are turning it into overall, we want to help companies get from bad data to good data, because that's where the problems are. People have very bad data and they want to get to better data. And so with Inspector, you can set up Inspector, and this is a hypothetical case of, okay, you're building a new sort of add to cart feature, but luckily you have just set up Inspector, and so that just happens that it's not cart viewed, it's cat viewed. Oh my God, the phone number story all over again. And so what do we do? Well, in most cases you wouldn't notice it, but because you just set up Inspector, you get a Slack alert specifically for your team. You know, you're on your team, you have a customized alerting for specifically the events that you care about, maybe the priority one events that you have built for your team. So I'm on the checkout team, so Inspector found a new issue on your checkout data. Event cat viewed looked very similar to the cart viewed event. Are you sure you want to ship that stuff? And if you do, make sure to fix it fast. And so I view the issue, and that brings me to Avo, which shows me sort of, okay, it's on the latest release here on iOS. I can find it. The status is unresolved, but I want to create a ticket around it. And I post a Jira ticket and ask a developer to fix this issue, ideally before we ship. And so they do. What a time to be alive. And then going forward, you will be able to monitor, because again, this is a journey from bad data to good data, you will be able to monitor the health of your events. So here are all of the events. Most of them have issues, some sort of issues, but gradually you want to get from to like the majority of your events not with issues. You want to go from a lot of unresolved issues to mostly resolved. And then you have sort of an overview of like, what are some of the priority events that you have? What is the health of those? And then you can also view this from sort of the lens of a specific team and set up custom alerts and monitoring specifically for that. So with that, I want to thank you all for joining us on this event. Thank you. And thank you, Harald, so much for hosting us. It's been really great. So we'll turn off these beautiful lights. And I'm sure everyone has run to various different places, but it's been a pleasure to have you here. And hopefully we'll get to connect. If not now, then on LinkedIn or Twitter or email or something like that.
We're not opening for questions?
Yes, so questions, if there are any, real quick now. Everyone's mesmerized.
I would say that when you explained to me what you were doing, I had no clue. Now I'm a bit closer to have some clue now.
Yeah, my pleasure. It's our pleasure. I never gave an AVO overview. I realize that now. AVO, I'll do it now. AVO fixes data quality for product analytics. What that means in practice, I'll go to the front here. So we have it. I have an R for refresh, I think. Yeah, we fix data quality for product analytics. What that means in practice is we have customers like Adobe, Wolt, Fender, IKEA, Boost. They all have a mission to build great user experiences. We have a mission to inspire them to have better data cultures so that they can build better user experiences. And ultimately, we have the sort of self-serve analytics governance workflow, and we have observability tools, and we have implementation tools for developers to do this in a more streamlined way. And that's it. Thank you. Let's go. Let's stand up and grab a drink and mingle if we have anything.